without. So let us try to complete it. And sometimes I may ask someone to share your screen while completing these activities. That will be helpful for all others also. You don't need that. Oh, I didn't complete the circuit, but how can I share? No worries. I am here to help. Okay. Yeah. So now let's start with the 1-bit full adder. Let's start with the 1-bit full adder, which we performed in the previous class also. Let me quickly share my screen. Okay. So that, just give a second, please. Let me go to this and then go to, okay, good. Yeah. So now let's go and start building the 1-bit full adder, which we already performed, but let me quickly give you the another example. So how do we build the full adder? For the full adder, that will be built from 2 half adders, correct? So here, let me use this box here to build the full adder. Suppose the input A is equal to 1, and if input B is equal to 1, then by adding A plus B, this will be equal to 1 plus 1, correct? So the result will be 2, numeric 2, and in the binary, that will be equals to 1, 0. So where here 1 is the carry. So we'll try to build a full adder for this. So first, what is happening here? It is going to add A and B. So for that, we need to select a XOR gate to add these two inputs. Input A and input B. Okay. So let me name them, like this is input B. Go to level direction, click on down to leveling this, then click on first input, name it A, click on level direction up, then click on gate and give the name, okay, give the name X or gate 1 and let me label it up, right? So let me save this as save online, give the name 1-bit full adder and just save it. Okay, just update this 1-bit full adder. Then let me go back to the dashboard and here finding the 1-bit full adder which is just created. So click on launch. Okay, let me maximize it. And then I need to check whether adding this A is equal to 1 and B is equal to 1, is there any carry? So to check the carry, if both the inputs are 1, then the result is 1. That is the property of AND gate. So I select the AND gate, name it as, let me name AND gate 1. Click on label direction, click on up. Okay. So then the two inputs for this AND gate are the same inputs of XOR gate 1. First input and second input connected to the second port of AND gate 1. To check 1 and 1, the result will be 1. So that is the carry here. So next, we know that this carry in from here, the bit 1 is the carry, right? Bit 1 is carry out bit. It is carry out. And bit 0 is the result, or we call sum. So carry out will be given as an input to carry in to the next upper column. Correct? So then that carry in will be added to the next upper column. So again, it requires for addition one XOR gate. I give the name for this XOR gate as XOR gate 2, the second gate. And to check for the second column, is there any carries or not? For that, another AND gate will be selected to design one full adder. I'll label it as AND 2 gate. Let me click on label direction like up. Then one input for the second XOR gate is the carry out of the previous column will be given as an input to the next column. Okay, so that is carry in. So let me click on this input button, go to orientation, select the down, so the port will be come down. Then connect this as input 1 to the second OR gate. So that is the carry in. Let me write C in. So that is actually the carry out of the first column. Carry out of first column. Does that make sense? Are you following this? Does that make sense?
Yes, sir.
Good. Okay. Right. So now let us see after second column, what will be the final output? That final carry of the result. So for that, let me first, connect this circuit or build this circuit. The output of first column is connected to the input to the second column XOR gate. So 1 plus 1 is 1, 0. So output here is 0. So let me connect the output here. Okay. And check what is the value. Let me change the orientation of this output to down. Let me connect it with the output data path of XOR gate 1 and give the name it as output 1. Okay. Output 1, that is 0. So that 0 will be added with the carry in. So for the first column, there will be no carry in, but for the second column bits, there will be carry ins will be there. Okay. So similarly, we'll try to connect the output for the second, the AND gate. Let me change the orientation of this port. Click on orientation, click on down, then connect this output with this port. So when 1 and 1, the result is 1. That is the first carry. Let me say carry 1. Okay. So for the second gate, the same inputs will be given as an input to the second AND gate. The first input is Cin and second input is the XOR gate 1 output. And then connect the output. So let me connect this output, change the orientation down, then connect this output with this memory unit. So this is the carry 2. That means next column carry. Let me just simplify this like carry 2. And the final result of the half gate is connecting this memory. Let me write the overall sum. Go to the level direction, up, connect this output data path to this memory unit port, input port. So then in first half adder, there is a carry. In the second half adder, there is a carry. Then the overall carry is computed by adding these two carries. So that is the final carry. Okay. So first input is gate 2 and gate 2. Output data path connected to the input data path of OR gate. Let me make it up. And the second input is the output data path of AND gate 1. Okay. And let me just connect it to this. And then it records the final output in the memory unit. Let us say the final carry. So that will be used for the next full adder. So let me orient this up and connect this. So here now you can see the bit combinations. Okay. 0 plus 0 plus 0. 3 zeros. What will be the result?
0?
Yeah, the sum is 0 because 0 plus 0 is 0, plus 0 is 0. Sum is 0, carry is also 0. Now, A is 0, B is 1. So 0 plus 1 is 1, and 1 plus Cin is 0. So sum is 1, and there is no carry. If A is 1 and B is 0, so 1 plus 0 is 1, plus the third input Cin is 0. So 1 plus 0 is 1, and carry is 0. And if A is 1 and B is 1, so 1 plus 1 is 2. So 2 plus 0 is 2. In the binary form, that is 1, 0. 1 is the carry and 0 is the sum. Is that make sense?
When does Cn change between 1 and 0?
Sorry?
I said for Cn, you have it set at 0, but when does the value actually change? Like what actually changes it?
Yes, that's a good question. I appreciate it. Now, at this point, you can see 1 plus 1. You're finding the final carry is 1, right? Correct?
Yes.
Yeah, that's good. So now, let me just delete this. Okay? Right. So now, let me copy this by clicking on Control A. This circuit is selected. Good. So now let me go to giving some space here and let me click here somewhere and Control V. Oh, sorry, Control A, then Control C, copy it, select space area here, let me see here, and Control V. Oh, so Control V. What? My keyboard is not working. Okay, Control V. Got you? So let me give the name here is this one. Let me name circuit 1. Circuit, suppose 0. Okay. Let me just delete this. Okay. Let me use the text here. Let me write. This is circuit 0. Does that make sense? This one is circuit 0. Okay. Or I can select this entire thing as circuit 0. Okay. Let me increase the column. Okay, let me increase the row. Yeah. So this one is circuit 0. And I'm having circuit 1. So here with 0 C in, how many combinations I checked here? One is 0, 0, 0. Correct?
Yes.
Let me write here the combinations. 0.0.0 is one combination. Next. 0.0.1. Assume here the first column is C in. C in. And second one is assume A. Third one is assume B. Does that make sense?
Yes.
Good. Okay. C in is 0, A is 0, B is 0. C in is 0, A is 0, B is 1. Then C in is 0. Then A is 1. B is 0. Right? So then C in 0. A is 1. B is 1. So all the combinations are done, right? 4 combinations. So you can check it here. C in is 0, A is 0, B is 0. The result is 0. No carry. Then A is 0, B is 1. The sum is 1. No carry. C in is 0. Then A is 1 and B is 0. Where C in is 0, sum is 1, carry is 0. Correct? Then if A is 1, B is 1, and C in is 0, in that case, sum is 0, carry is 1. Perfect, right? So
Yes.
now, what happens? This carry will be given as an carry into the next column, right? So C in become 1, correct?
I have a question. Like that's where I'm confused. That like when does C in actually like what in the circuits actually makes C in flip between 0 and 1?
Because we are going to test all the combinations for 2 to the power of 3 combination, that is 8, right? 3 bits,
Oh,
we are adding 3 bits here.
so right now it's the C in's more it's like a testing like right now we're just testing it, but we haven't discussed yet like how it actually changes.
Yeah, well, because when both the inputs are same, that is one high, then it will change.
The C in?
Yeah, when both A and B both are high, then it
Okay.
will change. The C in will be changed.
So while so pretty much when A and B become 1, it flips the bit in C in, and then that's what flips it between 0 and 1.
Yes.
Okay.
Yeah, perfect. So now let us go with your extension of your talk. So now At this combination, C in is 0, A is 1, B is 1. So it generated a carry. Now this carry goes to carry into the next column. So how we connect it? For the second circuit, let me make it clear for another bit. Assume that this one is 1-bit full adder. Now adding another circuit become 2-bit full adder. That means 2 columns will be there. Okay. So the output of previous column bit or previous circuit will be connected as the carry out, final carry out. Let me write final carry out become the carry in to the next column. So the one become the carry in. So let me just decorate it here. Yeah. Does that make sense now? So
Yes.
now C in is 1, then start combination now. C in is 1, set A is equal to 0. If A is 0 and B is 0, then what will be the result? If A is 0, B is 0, and C in is 1. So that is 1 plus 0 plus 0 is 1. Sum is 1, and there is no carry, correct?
Yes.
Yeah. So now with this C in 1, it goes on 1. A is 0 and the combination of B is 1. Then check what's the result. If A is 0 and B is 1 and C in is 1. So that is 0 plus 1 is 1. 1 plus 1 is 2, correct? 1 plus 0 plus 1 is 2. So that is 1, 0. Carry is 1, sum is 0 here. Got you? Then the next combination, C in bit is 1, suppose, and if A is equal to 1 and B is equal to 0, where C in is 1, okay, let me just delete it. Then what is the result? C in is 1, A is 1, and B is 0. The result is 2, so that is 1, 0. Then the next combination is when C in is 1 and A is 1 and B is 1, then what happens? 1 plus 1 plus 1 is 3. So A is 1, B is 1, C in is 1. So that is 3, that is 1, 1. Sum is 1 and this 1 is there. So that will be the final carry out of this second circuit, correct? So let me just annotate, yeah, let me make it circuit 2. Oh, sorry. Yeah, let me increase. Right. So second combinations are also done. So then 3-bit combination is over. So it goes to the 4-bit combinations then. So the next column starts again. So when next column starts, the another circuit is required for 4-bit. Control V. Okay.
So what we have right now, like the two we have right now, are that's just like a 2-bit circuit adder?
Yeah, this is 2-bit adder, correct.
Mhm.
Yeah, this one is 2-bit adder. And okay, let me just increase this. Yeah. So then go to the 3rd-bit adder. For another bit, another full adder is required. So let me just click somewhere here. Control V, right? So let me delete this C in and the C out of previous column will be the C in of the next higher column, that is circuit 3. So let me give the name for this circuit.
Okay, so I know for circuit 0, so you set that
Yeah.
so by default the C in is going to be 0, and the only time C in will flip is based off the previous circuit.
Yes.
The
Let
only
me,
thing I'm confused with is that how does the circuit 0 start? How does its bit get changed? If there's nothing going into that one, what changes its bit then?
yeah, I'll come to that one. Let me give the leveling of this.
Okay.
Okay. I'll come to that. That's a great question. I appreciate it. Circuit 2. Okay. Let me write it here like circuit 2. Let me arrange this bit here. Please follow the same for your assignment as well as for your class activity also. So this is for third bit, and I repeat the same for the fourth bit. Okay, let me remove this C in. The C out of third column is the C in of the fourth column bit. Okay, and let me decorate it as, okay, with this is the circuit 4 for the fourth column. Okay, let me just make it design. Yeah. So give the text field here. Circuit 3. Okay, and then, right. So these are the 4 circuits that we called, we can give the name as 4-bit full adder. Okay. So now let me stop the screen this. Let me use the PPT here. For the first one, first half adder, what we did, if input A, input B, and the C in, the 3 bits, okay? A, B, and 3 in. If A is 0 and B is 0, what is the result? 0 plus 0 is 0, and if C in is 0, so what is the sum? This 0 plus 0, then 0 plus 0. So for this 0 performed first, then the result of this is performed next. So that's why here is one XOR gate, here is one XOR gate, and the result is 0 that is stored. Okay, and here we use the one AND gate for adding these two. Is there any carries or not? So AND gate properties, if both the inputs are 0, result is 0. If input 1 is 0, B is 0, suppose, the result is 0. If 0, 1, result is 0. If both are 1, then the result is 1. So the carry bits comes only when both the inputs are 1s. Both the inputs are high. So like that, A is equal to 0, B is equal to 0, and C in is equal to 0. The result is 0. Second combination, A is 0, B is 0, and C in is 0. Sorry. If A is 0 and second input B is 1. So 0 plus 1 is 1, plus 0 is 1. There is no carry here because one input is low, one input is high, and C in is low here. Another combination, A is 1, B is 0, and C in is 0. So 1 is high, second one is low. So 1 plus 0 is 1, plus 0 is 1. No carry. But when both the inputs are high, A is equal to 1, B is equal to 1, And if Cin is 0, so in that case, this 1 plus 1 is 2, plus 0 is 2, that is 1, 0. So this is carry out of this column. So where it goes to carry in of other column when there is a multiple bit addition. So multiple bit addition means if the A value is 1011 and B value is 1111, suppose A is equal to 1010, B is equal to 1111. So this is multi-bit binary addition, if you recall the operation. So this is the 0th column. Then this one is column 1, column 2, column 3. So that's why we have given the circuit name circuit 0, circuit 1, circuit 2, circuit 3. Does that make sense?
Yes.
Whatever. Good. Okay. So first, the circuit 1 is performing adding first column. That is 1 plus 1 is 2. So this one is sum. 1 is here. This one is carry out of the first operation. So this carry out become the carry in to the next circuit. So let me use that as 1 here. So this is become carry in to next column. So then it is adding 1 plus 1 is 2 and 2 plus 1 is 3. So it generates 1, 1. So this 1 become the carry out of second column. So that become the carry into the next columns. So this 1 plus 0. So if there are all ones, if both the inputs are 1, then there will be definitely a carry out and that will become carry into the next column. Does that make sense?
Yes.
Good. Okay. So this is how the first circuit is the 1-bit full adder. Let me just share the screen. Yeah. So what you do, the first circuit is the 1-bit full adder for the first column. Second circuit is the 1-bit full adder of the second column. Third circuit is the 1-bit full adder of the third, and so on. So what is happening if first column is having both the inputs are 1? Because for the initial column, the input carry in is always 0, correct? For the first.
Wait. So okay, that's where I was actually getting. Okay. So the Cin for the first bit is always going to be 0?
Yes.
So okay.
Yeah.
So okay, because I know you said so the first bit adder for the carry in will always be 0 no matter what. Like nothing can change that.
Yes, that's correct. Because
Okay,
the
yeah.
addition starts from the least significant column to most significant column. So this one is the least significant column. It won't have any initial carry ins.
Okay. That's where I was confused. Thank you. Now that answered my question. I'm
Okay.
good.
Yeah, thank you. Thank you for that. So now come to the Nicholas question. Nicholas asked that about the class activity 5.2.6. So in 5.2.6, it's asked to build 1-bit full adder. So what you do, whatever the circuit which we have created, the first one. So let me simply click on plus. Let me write 1-bit full adder. Let me say, okay, let me come to this. So this is the circuit which we built. Okay. Just save this, save online. Okay. Nicholas, are you getting the point?
Yes, sir, I see it. Thank you.
Good. Okay. So this is 1-bit full adder. So you just save it, then go to dashboard, go to 1-bit full adder in your circuit area, click on more. Oh, okay. Here I just use for this. So click on more. So click on embed, click on publish, then come to Canvas page, and the class activity is 5.2.6. Go to the reply, click on reply, then in the text field, at top right bottom corner, click on this, the HTML editor field, then Control V, then click on save. So this is what do. So once this is here, then anybody can check by C in is 0, and A is 0, B is 0, A is 0, B is 1, A is 1, B is 0. And if both are 0, there will be a carry. When there is a carry, then it go for the next circuit here, the second circuit base. Does that make sense for everyone? If both are 1s,
Yes, sir.
carry is
Makes sense to
1.
me.
Yeah, good. Okay. Yeah. So let me design it. So, and your next discussion is we are having what is the next discussion? It's a 4-bit addition and subtraction. So I'll give you 5 minutes time. Those who have not completed this 1-bit adder, please complete and post your response here. Just take 5 minutes, Tim. All the others, those who completed, please take your coffee break. Is that fine from everyone?
Yes, sir.
Yeah. Thank you. Let's take 5 minutes break and we'll come and complete 1-bit subtraction also. Meanwhile, I'll just mute it, not to disturb others. Shall we good to go?
Yes, sir.
Perfect. Okay. So let me share the screen. Okay. And okay. So let us come back to the circuit here. Let me go to my dashboard. Come to the phone. So up to now we have done the 1-bit full adder. Correct? So now what we'll do, we'll try to make a 1-bit subtraction. 1-bit subtraction. So for that, let us take an example like R is equal to A minus B. This is a subtraction operation, right? Do you feel or not?
Yes, sir.
Very good. Okay. So the next is minus B is a negative number, so we use 2's complement. So how do we represent minus B in 2's complement? So minus B, to convert this into the 2's complement, okay, that is approximately what we do. We do the 1's complement first, right? That we write like minus B. So first B binary will be written. If you recall the 2's complement. So that will become 1 and B binary representation. Binary. Okay. Input B binary representation. So there, after that, what we did, minus is sign bit. So what is the sign bit? Sign bit is set to 1. And the second one is binary is having its magnitude bits, right? Magnitude, sorry. If we any typo mistake, just take it magnitude bits. So then you do the 1's complement plus 1 is equals to 2's complement. Correct? Yep. So then the above equation will become like R is equal to A plus the 1's complement of B. Let me write it as like B plus 1. So now there are 3 bits, like the 1 full adder operation which we did. So in this case, to make the B as 1's complement, so what we do, just drag this B input here. So B will be doing the 1's complement for this. So how we do? Here the C in become, okay, 1, because in 2's complement 1 is added. So for inverting this bit, if you recall the simple AND XOR gate, if giving 2 inputs, for example, 1 bit is second input, and just let me connect the output. If you recall, if 1 bit is 0, another bit is 1, the result is 1. If input 1 is 1 and input 2 is 0, result is 1. So it is inverting the bits, right? For 2 inputs. The same way, here we can use one more extra and okay, XOR gate to invert the bits. To invert the bits. So that is inverting the B bits. So what is there? It is 2's complement. So input 1 is always 1 for inverting the bits. Okay. If bit, and then the output of this XOR gate, let me write inverter XOR gate. Inverter XOR gate. Let me put it down. Leveling, sorry. Let me level down it. Okay. And the output of this inverted bit will be added with the input. Okay. Does that make sense? A plus inverted bit of B. Does that make sense? A plus inverted bit of B. Let me write here, change the orientation up. Let me connect this here. See, if B is 1, its inverted bit is 0. If B is 0, inverted bit is 1. Does that make sense?
Yes, sir.
Good. So A plus inverted bit of B plus 1. 1 is C in. Okay. So this is 1 bit subtraction operation. This is 1 bit subtraction operation. So now you can check it that if A is equal to 1 and B is equal to 0, so 0 inverted bit is 1. So 1 plus 1 is 2, 2 plus 1 is 3. So final carry is 1, sum is 1. If A is 0 and B is 0, so that inverted bit is 1. So 1 plus 0 is 1, plus 1 is 1, that is 2. So that is 1, 0, 1 is carry, sum is 0. Okay. When B is a negative number. So for this performing negative operation, one more extra OR gate is added. So this is 1 bit. To make this as 1 bit adder, simple adder only, C in becomes 0, as you said, the previous doubt. If it is adder means A plus B, it don't require any input, correct?
Correct.
Yes. If the second operand is the negative operand, then C in is set to 1. So this is 1 bit adder. If C in is 0, 1 bit adder. If C in is 1, 1 bit subtractor. I hope it's clear for everyone, right? If
Yes,
it
sir.
is clear, can you please say yes in the chat box, please? If you all okay, then yeah, good.
Mhm.
Wonderful, wonderful. Okay, so this is just for 1 bit. So let me use this another circuit. Let me write. In our question, we are having 4 bit adder and subtractor. Let me just write sub. So how to make this? So let me just copy this. Control A, selected, then Control C. Go to the next circuit. Control V. Okay. Control V. Let me just delete this one. So this is for 1 bit. So if I want to make it for 4 bits, how many circuits are required? Let me select this, Control A, Control C. This is 1 circuit. For the second bit, another circuit is required. And how it will be connected? This C in is the C out of previous column. For third bit, another circuit, another 1-bit subtraction circuit, Control V. So this C in is the C out of the previous column bit. Connect this. Then for the fourth one, let me just create one more circuit for the fourth one. Delete this C in here. The C out of previous column is the C out of, C out of previous column is the C in A of this column. So does that make sense? This is a 4-bit adder and subtractor. Does that make sense?
Yes, sir.
Good. Okay. So then what we need to do in our assignment, if you look at here, in the discussion, if you go to 5.2.7, the class activity, 4-bit addition and subtraction. So what we do? Simply, we save this file, save online, go to dashboard, then go to the circuit which we created, 4-bit adder and subtractor. Okay, click on more, click on embed, click on publish, go to canvas, click on reply, and click on HTML editor, then paste it here and click on reply. So your circuit is ready. So if Cin is 0 means subtraction, if Cin is 1 means addition. So it's performing 4-bit because there are 4 circuits. So 4-bit adder and 4-bit subtractor. So likewise, if you want to build a 32-bit adder, how many adders are required? For 32-bit ALU, how many adders are required?
Would be 32.
Yes, exactly. We need 32. So I hope it's clear for everyone, right? If you agree, just give thumbs up in the chat box if you agree. Thumbs up, or you just type yes in the chat box. Yeah, Matthew, Gabriel, Victor, Jace, Marklo, Gabriel, Nadan, Device. Yeah. Is that easy? Is that easy to build the 1-bit full adder and the 1-bit subtractor?
Yes, sir.
Good. Okay, I appreciate. Yeah, this is what in this slide. So here the example is given for 4-bit addition and subtraction. Okay. So here the question comes, what are the 4 bits then? So the 4 bits are, in this example, if you go to this example, let me just launch this simulator. Okay. Go to facts field, let me write A is equal to 1010 and B is equal to 1100. So here for simple addition operation, let me just increase this. Okay. So let me give the bit positions then. Yeah, This one is the bit position 0. The next bit is at position 1. Next position is at position 2. Next one is at position 3. Correct? So these are the bit positions. 1, position 2 bit, position 3 bit, position 4 bit. Does that make sense now? So how do you give input to the circuit now? From leftmost bit to the rightmost bit. So here A is, first bit here is 0. So A is 0, second bit in the second circuit is 1, third bit in the third circuit is 0, fourth bit in the fourth circuit is 1. Similarly, give the input for B. For B is, first bit is 0, second bit is 0, third bit is 1, fourth bit is 1. And this one is a simple add operation, suppose. Just like A plus B. Simple add operation. So what is C in? C in will be 0 here, correct? Is that clear? For this operation, C in is equals to 0. If it is a negative operation like A minus B, then what is the C in here? For A minus B, C in is equal to 1. So we set C in is equal to 1. That's it. So that performs one bit addition and subtraction. Is that make sense?
Okay, so so when the C in is 0, it can only do addition, but when C
Yes.
is 1, it can do addition and subtraction?
Yes.
Okay.
Good. So this is for 4-bit. Now for 32-bit, suppose. How many circuits we need for 32 bits?
32.
Good. We required 32 full adder circuits. Like this. I hope it's clear for everyone, right?
Yes, sir.
Good. Right. So in the assignment, the question is asked, build the 8-bit. Is there any doubt from assignment 1? You can share your screen and please let me know so that we can quickly address those questions also. Or let me go through the assignment. In the assignment 2, the question is asked that, this is just for encoding, just adding bits only. I hope it's clear, question 1. In question 2, it is asking that build 8-bit wise AND gate. Is that okay, or do you want me to give demo for this 8-bit?
For can you do the demo? But in general, for an 8-bit, it'd be just like you could say 8 of the 8 circuits for the addition or 8 circuits for subtraction, right? 8. I could say 1-bit.
No. It is just only 8-bit wise operations. 8-bit and 16-bit, but as you said, I'll just go and create the 8-bit wise AND circuit. Okay. So let me write 8-bit wise and ALU. Okay. So let me click this. So what we need to do, it's saying 8-bit wise AND. So we need to select 8 AND gates. AND gate 1, 2, 3, 4, 5, 6, and 7, 8. Okay, arrange all the 8 gates in a parallel way. and then just give the inputs and connect the output data ports to this. So let me quickly connect E here, Control C. Let me connect Control V, Control V. Let me arrange them here. Okay. Yes, and Control V. Just connecting 16 inputs to 8 gates. Input 1 and input 2 like that. Control V. Right? So 16 inputs. Each gate takes 2 input and 1 output. 2 input and 1 output. Okay. This is a 8 bitwise and ALU. So this is raw. From this we can create a sub-circuit that I see like 8-bit and IC integrated circuit. So this will be open. Just here, click on circuit, click on insert sub-circuit. In the insert sub-circuit, select the 8-bitwise and just enter. So this one is the IC. So then just give the output, connect these outputs. And similarly, connect the inputs. Okay. This. Okay. So
There was a question in the
likewise,
chat real quick. I think someone asked a question in the chat.
yeah, likewise you can connect. So this becomes the first part here, that build a 8-bitwise and integrated circuit. Similarly, for the next question, it is build 16-bitwise OR gate. So instead of AND gate, when it is okay, yeah, instead of AND gates, we use OR gates, 16 OR gates. So
We just have
that
16 or gates on the for the thing.
yes.
Okay.
So that will be the second circuit that you will build. Then the 32 bitwise AND gate. So here we just use 8 and that will be extended to 32 bitwise. So 32 AND gates. Okay.
I think
And
someone asked
just
about the like the IC thing that you put on there.
yeah,
That was the question in the chat.
IC means integrated circuit. Yeah, you just build this and after that build this. So then you just embed this into the answer here likewise, which we did in the class activity. Just what we do, we go in here, we just save this and yeah, save online, then go to dashboard. And yeah, in this circuit we build it, go to more, go to embed, click on publish, come to assignment question. The second question here is this. So just embed here, paste, okay. And then if you click on submit, after pasting, after answering N1, when you paste it, okay, so your answer will be here. Does that make sense?
Yes, the question they were trying to ask, he was trying to ask before was, how did you get that? How you have right there the rectangle, the 8-bit wise? I think that's what he was asking. How did you actually get that on the screen? That's what he's
Uh,
asking.
which one? You're talking about this IC?
Yeah, he's asking. They were trying to ask like, how'd you get that?
Oh, okay. Let me go back to this. Okay. Right. So first we create this one, right?
Yes.
We arrange this. Yeah, sorry. So we create this 8-bit AND gates, then click on plus symbol here. Are you getting the point?
Yes.
Click on plus symbol. Just give the circuit name as we are saying 8-bit and IC, suppose. Give the name of the project. So then the new workplace will be created here. Okay. Got you? So the next, click on circuit here. Then click on insert sub-circuit. Then select the 8-bitwise and ALU, which will display here. Select that one button, then click on insert sub-circuit. So that gives the IC, integrated circuit. Is that clear now?
Okay, yeah. I see how it's made. So is this what you want us to turn in when we actually submit the assignment? That's you want us to turn in this for you?
Yes.
Okay.
Yeah, assignment 2 as well as the class activities. So hopefully today's session, it is also recorded in the Zoom. So you can go to cloud recording for your reference also to go back to this video, okay?
Yes, sir.
Yeah. Patrick, have a question that what do we add onto the IC? Yeah, we need to give the inputs, Patrick, here. Give the input, connect all input memory to input ports, and output memory to output port. That's all you need to do. And yeah, that's a good question. So in input 1, what is given for this? R0 is equals to 00001010. We have to give this input. So how do you give? First 0, then 1, then 0, then 1, then 0, then 0, then 0 and 0. So we need to give that input. After arranging them, give the first input like from top down. So first input is the 0 here, that is R0. So we give the first input 0. Then for the second gate, the second input is 1 for the second gate, correct? Second input is 1. Then third input is 0. Then fourth input is 1. So that is 0, 1, 0, 1. So the rest remaining inputs are all zeros for A. Okay. So let me correct them. 0, 0, 0, and 0. So these are the A inputs. And for B input, that is R1 is equal to all zeros, right? So the circuit, what do you give? First input is 0. Second input is also 0. Third input also 0. Fourth input also 0. Fifth input also 0. Sixth input also 0. Seventh input also 0. Eighth input also 0. And then we check what is the output of add this. 1 and 0 is 0. The next one is this 1 and 0. Let us check what is the output. The second is also 0. Then 0 and 0. What will be the output? The third one is 0. Then the next one is 1, 0. The result is 0. The next one is 0, 0. Let's see what the result is 0. Next one is 0 and 0. The result is 0. The next one is 0 and 0. The result is 0. And the next one is 0 and 0. The result is 0. So here you can name it as, let me write, or 0 input R0 input and give the R1 input column, okay, and then just give the output, the final result, that is R0 and R1 is the result. Does that make sense now?
It makes sense now, yes.
Yeah, perfect. Good. So likewise, you do the 16-bit OR gate, 32-bit AND gate bus. You are almost done 3 questions. The carries, one is 12.5 points, another one is 12.5 points, another one is 20 points. So almost 45 points of exercise that we have done. Is that clear?
Yes, sir.
Wonderful. So in the next lecture, we'll try to build, let me close this. In the next lecture, we'll try to build a 1-bit ALU, which is a integrated circuit that can either perform full adder or subtraction, or 1-bit and 1-bitwise and 1-bitwise or 1-bitwise exclusive OR. So that is based on the control signal that we will discuss in the next column. Next lecture. I hope today's session makes a lot of sense and to learn so many things. But please revise the video. That is the intention, because today's activities are most important. That's why I took online class, so that I can record, and that will be available to you for revision for further the rest of the semester also. Is that make sense?
Yes, sir. So you said this will be posted a little later on?
Yeah, sure.
And then I think someone asked a question in the chat one more time too.
Yeah. Can you read out?
They
Got
said, Professor, can you extend the due date for assignment 2 for one more day?
Oh, okay. That's a good question. So what I do, assignment 2, if the due date is today, Gabriel, or when it is? I'm not sure. Okay.
It is today. They were asking if you can put it for one more day.
Oh, okay. Not only one more day, I will give you another 2 days of time. So, yeah, you can complete it by next Monday. Okay?
Yes, sir.
Yeah, I extended up to next Monday so that you can enjoy. There is no hurry in that one.
Yes, sir. I appreciate it. Thank you, sir. This was a very helpful lecture. And thank you for
Yeah, definitely, because I'm here to help you all. So you can check it here. The March 30th is the due date. I hope it helps for everyone.
Yeah, I
Thank you,
do.
Patrick. Thank you, Gabriel, Paul. Yeah, Gabriel, please speak out.
I was gonna say I do like this, the more visual stuff you've been doing. This has been really, really helpful.
Thank you. But at the end of the semester, I request all of you to please give the course rating and teaching rating 5 out of 5. That helps me a lot. That boosts me a lot to align the course more practical.
Yes, sir. Of course.
Yeah. Thank you. Thank you all. Have a nice evening. Have a great weekend. See you all on next class with the happy faces.
Yes,
Thank
sir.
you.
Bye bye.
Bye bye.